Hello everyone, today I'm glad to introduce my dissertation. In this dissertation, I have explored the relationship between public sentiment and Bitcoin price movement direction, with the aim of optimizing the action recommendation model to maximize profits for trading Bitcoin. Now you might be wondering why I chose this topic, and why is it so important? Actually, the world of crypto trading is constantly evolving, and it can be quite challenging to make informed decisions in such a volatile market. That's where public sentiment analysis comes into play. Furthermore, most of the related work focused on the daily price movements or the relationship between public sentiment and the daily price returns, not the hourly. Due to the fact that the Bitcoin market is highly volatile, here is one of the questions. Does public sentiment influence the hourly price movement or returns? More specifically, to explore this topic, I proposed 3 questions for the study. Well, to explore the relationship between the public sentiment and the Bitcoin price movement, and to see if the public sentiment can be used as a valid indicator for the price movement prediction. To answer these 3 questions, we set 3 or more specific objectives for the study. To answer question 1, we collect Bitcoin-related information from multiple social media platforms, exploring the relationship between public sentiment and Bitcoin price fluctuations, and the time-lagged impact using statistical techniques and sentiment analysis. For question 2, select the optimal model to predict price fluctuations and price returns using deep learning models, and then select related public sentiment as features to optimize model performance and enhance prediction accuracy. For the last question, construct an action recommendation model using the optimal prediction model and adjusting thresholds to maximize profits within specific time intervals. Well, following these objectives, we start off the study using the adjust CRISP-DM architecture. First of all, we use the data from multiple platforms, including data and Google Trends, Reddit posts, and tweets and tweet volume. All of this are grouped by hour and over the period of 6 months, from 1st January to 30th June 2022. Google Trends is collected at weekly intervals, and we need to rescale it to the whole 6 months time frame. For tweets and posts, we performed sentiment analysis and used 3 different sentiment analysis tools like Wonder, TextBlob, and PassSentiment to obtain a sentiment score. The correlation between Bitcoin price and public sentiment was analyzed using statistical methods, like Spearman correlation for direct correlation analysis, while the Granger causality test was used for causality testing in order to determine which social media data had a lagged effect on the returns of Bitcoin price and the direction of price movement to select the suitable input features. In the process of model selection, we chose RAMA and the Random Forest Classifier as the baseline models for the regression and classification problems, and compare them with deep learning models. Finally, select the optimal model and optimal features as the input of the action recommendation model. The framework of it is shown here. For example, when the probability of the price going up is greater than the threshold, we will do the buy operation. The threshold is set by ourselves. Well, as mentioned before, the answer to question 1 can be obtained from the process of feature selection. For the first stage of feature selection, the data needs to undergo preliminary selection. It can also be seen that the direction correlation between all 3 types of data and the price of Bitcoin decreases as more data is added, and at the same time increases again for the 6 months of long-term data. Therefore, the next study will focus on 1 month of data and 6 months of data. For Reddit posts, the correlations obtained from both treatment and week and similar. In this case, the second stage of feature selection, where Granger causality testing is used. It shows that the weighted sentiment score of Reddit posts has a lagged impact on price movement. So in this case, we use a weighted sentiment score instead of unweighted score. Actually, from the outcomes of Granger causality testing, we could answer question 1. It has been found that the hourly twist compound scores has predictive power for price movements in the short term. The predictive power seems to work on the price movements after 2 hours and lasts for 9 hours. But in the long term, the impact of Google Trends and other sentiment scores starts to emerge. Furthermore, to answer question 2, the optimal model is selected during the process of model selection. In the initial stage, we compare the performance of a ARIMA model and LSTM in predicting the Bitcoin price and returns. It shows that LSTM model literally outperformed the ARIMA model, not only from the outcomes of metrics, but also from the clause of generalization. We utilize the autocorrelated lags from the ARIMA model to serve as a time step for predicting the returns. It also showcases the lagged predictive power of Google Trends on return prediction, with the R-squared score going up. Then we shift to price movement predictions. In this case, LSTM model is still the most outstanding model, which is going to be optimized using the features obtained from feature selection. We tried different combinations of the major features to explore their predictive power on price movement. The interesting thing is that we found that the accuracy in the short term has incredibly increased by 3% to 8% by adding the twist compound score as one of the input features. In the long term, the combination of Google Trends and twist polarity score can get the highest accuracy. It seems like Reddit posts can't have a strong influence on price movements. For the last question, we leverage the 10-lagged twist compound score as an additional indicator to optimize the auction recommendation model. We invest $100 and buy Bitcoin on the first day, regardless of whether it goes up or down the next day. We then automatically buy, sell, and wait according to the recommendation model over the course of a month, and then calculate the total return. Finally, we found that the maximum return of the optimized model was 21.79% higher than the baseline model. Similarly, for long-term data, Google Trends and twist polarity scores increased the 6-month maximum return by almost 21%. It's clear that all of this demonstrates the predict power of various public sentiment indicators for both short-term and long-term Bitcoin price movements. Overall, compared to the previous work, this study focused on hourly price movements instead of daily data and price returns. In addition, this study optimizes the trading recommendation model using hourly social media data and tests it on both short-term and long-term data, and the results demonstrate the long-term impact of Google Trends on hourly price movements. Although we explored and manipulated the data as much as possible, there are also some limitations on the study, and due to the data scope or models. Meanwhile, on the other hand, what got me thinking is whether the tools we use in the sentiment analysis step can be optimized. For example, with a deep learning-based sentiment analysis model, will we get more accurate sentiment scores and try to accurately express the public sentiment? I think it's worth trying if I have more time. For further work, we'd like to explore the different data sources to cover more social media indicators and cryptos. In the future, we'd also like to explore different approaches to sentiment analysis and optimize the data wrangling process. The above is a brief summary of this study. Thank you for your attention and time.